Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is
2 times length plus 2 times width.
Good afternoon and welcome to another edition of Count on Us, where you, the students, are the stars of the show. You call in with your homework questions, and we're here to help.
Yes, we are.
I am Mrs. Jennerette.
And I'm Mrs. Jax.
And here we are. Happy New Year, even though it's January 13th.
Happy New Year to you, too.
We haven't seen you all since 2013. So we're here to answer any of your homework questions. We have challenges for you. You know that we are here, the elementary show, from 4 o'clock to 5 o'clock. And you can reach us at, it's on the bottom of the screen, look at that, 301-772-0080.
Yes, and you can always email us. The email address is COU at, let me just make sure I have it right. I'm sorry. You can email us at COU at PGCPS.org. So that is correct. The COU stands for Count on Us. We know PGCPS is our server, Prince George's County Public Schools.org. So you can email any questions that you have. Maybe the lines will be really busy tonight and maybe you don't get a chance to get your question asked. So you can email the question and a student may answer your question on our email corner.
So those of you that are watching, you know we're on Comcast Channel 96, Verizon Channel 38. Call your friends. Tell them to tune in. And you can also view us on the web.
Absolutely.
On our PGCPS homepage. Click the link and you'll see us on the web as well as the television.
Yeah. So if you are somewhere out and about and you don't have your TV with you, of course, at that point, you can use one of your devices go on the web and you can
your Christmas gifts.
Absolutely. I'm sure some of you have brand new tablets or new cell phones out there that you can access the website and you can view us that way.
All right. So
if I'm a caller, what could I possibly gain from calling? Like, what is the whole point of me calling? What is the reason that I would be calling? What, not necessarily monetary reward, but how does it benefit me to call in?
I'm so glad you asked that. Let's say you had a problem in the classroom and maybe you didn't have an opportunity to ask your teacher for some assistance. And so you're sitting at home and you're looking at it and you just want some clarification or some assistance. So you would call that number on the bottom of that screen and Miss Jax or I will assist you with that problem. You read it to us, we write it out, we work it out together. Just know that we're not going to give you the answer. We're just not going to say, oh, it's 85. We're going to ask you questions to get you to the right answer, and then hopefully with our discussions you'll be able to say, oh, you know what, I get it.
Okay, so it's kind of like getting the extra help that I might need if I'm stuck on a homework problem. I can't call my teacher. Maybe my mom or dad or older sister or brother can't really help me or may have some questions about it as well. Then that means I could call the number at the bottom of the screen and someone will answer my question live and help me walk through it?
Yes.
Wow,
Live.
that's wonderful.
Real time.
Okay.
And in addition to that, we have some challenges, some math that you might want to call in after you give us a question from one of your homework assignments or something you did in class, and then you could show us how much you already know. So we're going to look at our challenges and our absolute favorite of the students. I know we do this in the schools as well, 24 challenge. What we have is a card. We have 4 cards labeled A, B, C, and D. And what you do on the cards, you have to use all of the digits once, and you have to make the number 24. And you can use addition, subtraction, multiplication, or division. You can add all the numbers, you can subtract, you can use a combination of the 2, of the 3, of the 4, but your goal is to make the number 24. So what we're going to do, we're going to read the digits on the card and then write them down, and then when you call in, let us know which card you want to do, and we'll see if you get 24.
Okay.
So let's look at card A. We have the digits 1, 5, 2, and 9. I know this is a 9 because there's a red dot, and that signals to me that that is a 9. So that's card A.
Okay, and card B, we have 3, 4, 7, and 2.
Card C, I have 4, 2, 4, and 6. Notice this does not have a red dot, so this is a 6.
Okay, and card D, 7, 2, 5, and 3.
So these are our cards for our 24 challenge. Hopefully you wrote those numbers down. We're going to show you our second challenge.
All right. I love a challenge.
And the second challenge, I really hope someone attempts.
Look at that. What could that be?
Oh my goodness, go Corlam.
What in the world is that? Well, it has to be a mathematical term. And as you can see, it says word scramble. So that means that the mathematical term is here. It's hidden. You can't see. And these letters are scrambled. Your job is to unscramble it and then call us with your guess.
So those of you watching, write those letters down, scramble them, unscramble them, call us when you know the word, and you'll get your name in our fabulous treasure box.
And you'll be seeing that treasure box in just a second. Here it is. The name goes in the treasure box. So this treasure box, how does my name get in here? Is it just from the challenge?
No, it's not just from the challenge. Your name will go into the treasure box when you call and give us a question that you would like assistance with. But if you do the challenge, guess what?
What?
You get your name in the box 2 times, and then what we do at the end of the show, we shake it up, we draw a name, and that person gets a prize sent to their school.
All right, that is so cool. So that means if I call in, my name goes in once. If I do a challenge, my name goes in a second time. Wow, so that's increasing the probability that I could win.
Yes.
All right, increasing my chances. So make sure you call us. The number's at the bottom of your screen, 301-772-0080. Call us at this time. We are ready to answer your questions.
Yes.
Okay? And while we're waiting for phone calls, we are going to discuss some of the new topics that 3rd, 4th, and 5th graders are working on at this time. I guess we can also talk about kindergarten, 1st, and 2nd if we have any callers.
Oh, yes.
I know with 3rd grade, some of you 3rd graders out there are probably focused on fractions. 4th grade will be moving into some new exciting skills in geometry. Ooh. Yeah. In 5th grade, I think you all are going to be moving into graphing and order of operations. So we can probably talk about some of that today.
Okay, that sounds great.
Okay.
Well, let's start with 3rd grade because I know they're starting with fractions, and they have a wonderful term in 3rd grade called unit fractions.
Unit fraction. What is a unit fraction?
Well, let me share with you.
Okay.
Let's write it on our
You'll be able
paper.
to see it on your screen in just a moment. Okay. I think I lost my battery.
Unit fractions. What is a unit fraction? Well, let's look at a fraction. Our fraction, 3/4. We know our numerator, the number that is above the line, that tells us how many parts, and our denominator tells us the total parts. So I just wrote down any fraction, 3/4. Now, 3/4 is not a unit fraction, but 3/4 can be broken into unit fractions.
Okay.
So a unit fraction is a fraction with the numerator of 1. So what I'm doing is taking the fraction 3/4 and decomposing it into the unit fractions.
I like that term, decomposing. I'm sure you all have heard that from your teachers. That is definitely a word from our Common Core state standards. Students who are in first grade now should have heard that last year from their kindergarten teachers. Decompose and compose numbers. But okay, so decompose, that does that mean to break this down into smaller units or pieces?
Break it down into smaller units or pieces. And what's so wonderful about the unit fractions, we see how the unit fractions work like whole numbers. We're taking a fourth, 1/4, and adding 1/4 and another 1/4. That's
Okay.
1, 2, 3. So that's how we can take the fraction 3/4 and decompose or break it down into the unit fractions of 1/4 and 1/4 and 1/4.
Okay.
And you know what will be so cool? But you know what? We probably don't have the
fourths.
fourths.
No, but we have.
So let's do another one with what we have. Oh, you know what though?
we
do
may have something over there with
fraction bars. So I'm going to make, hopefully, 3/4. I'm looking for my, there we go.
All right.
Here's a unit fraction, because that's 1/4 plus 1/4 plus 1/4. Whoops, let me turn that. I doubt you could see the fraction on there anyway, but anyway. 1/4 plus 1/4 plus 1/4. I compose, I put them together. This equals 3/4.
Look at that. Do we have any eighths in there?
We certainly do.
I wonder if we have 6 of them. Let's see what happens.
Oh
we
my
take
goodness, it would be nice if we had
6
6
eighths.
I have 1/8, a unit fraction. 2/8.
Oh, we can still, if not, we can still work out the eighths and the fourths though. We'll see what happens.
You know, and I think we do have all of our pieces. They're just
All right.
hard to see because I have old eyes.
I think this is it. This is it.
There we go.
And this is going to move us into our 4th grade standard of comparing fractions.
Yes.
Oh my goodness. So the yellow ones are fourths, and we have 3 of them. You showed us earlier 1/4, 2/4, and 3/4. So we have 3, and I'm just separating it just so you all at home can see. But now when I put them together, we know this is 3/4. But under here we have some smaller pieces, and they're called eighths. Well, I wonder how many eighths it will take to match up or to equal 3/4. We have 1/8, 2, 3, 4, 5, 6. And I'm spreading it purposely so you can see that there are 6. And now we're going to put them together. So look at that. So 3/4 is equivalent to 6/8.
It would seem so.
Wow. Okay. So does that mean when this fraction down here, 6/8, takes up the same amount of space as 3/4, that they would be equivalent?
They are equivalent. They are equivalent, just as Ms. Jack said. They take up the same amount of space. They represent the same part. They name the same total part, 3/4 and 6/8.
Look at that. Okay.
I'm going to write it down here.
Oops. So 3/4 equals 6/8. All right, and let's look here. I want to look at the 1/8, which is a unit fraction, compared to the 1/4. It definitely looks like the 1/4 is bigger and the 1/8 is smaller. I wonder how that's possible when a 4 is bigger than an 8. I'm sorry, a 4 is smaller than an 8. But here in this piece is larger than this piece. How can that be possible?
Well, let's look at one whole. And you know what? We're going to erase.
You want to use a different color?
And let's erase. We learned about unit fractions, which was 3rd grade. And a unit fraction is a fraction that has 1 as a numerator. we created equivalent fractions. We used our fraction bars to show that 3/4 and 6/8 name the same part. But let's just look at 1/4 and 1/8. Why is 1/4 larger than 1/8? 4 is smaller than 8.
It sure is. I wonder how that's possible.
Well, let's take a look at 1 whole.
Oh.
This is
Okay.
1. 1/4, we know the numerator represents the number of parts, and the denominator represents the number of total parts. So we are taking this whole and we're dividing or partitioning our whole into 4 equal parts. So the bigger our parts, ran out, the bigger our fraction.
Okay. So we definitely can explore this in a little while. We're going to go to the phones in just a moment. We see that Omar is holding on. So we will come back to unit fractions, and we'll come back to explaining and going over why one piece may be smaller than the other piece, even though this fourth, the number 4, is smaller than an 8. A smaller number than an 8, but the piece is larger. So we'll continue to talk about that in just a moment. It looks like we have our first caller of the evening.
All right.
All right.
Hello, caller.
Hello and welcome to Count on Us.
Hello.
How are you?
Good.
All right. What school do you attend?
Huh?
What school do you attend?
What school do I go to?
Yes. What school do you go to?
attend.
I go to Allenwood Elementary.
Allenwood Elementary. And what grade are you in?
Second.
Second grade.
yeah, second
and your name is Omar?
Yes.
Okay, Omar, guess what? I can hear myself on your television at home. So, Omar, you're going to have to turn that television all the way down or press the mute on your remote control. I know you know how to work that remote control. My daughter's in second grade and she knows how to work the remote control.
My 3-year-old does.
So, press mute or turn the volume all the way down and only listen to us through your telephone, okay? You can still watch the television.
Yes.
But just listen to us through the telephone. Is that okay, Omar?
Okay.
Oh, all right.
All right, thank you.
Okay, so Omar from Allenwood Elementary in second grade. What is your question today?
My question was that if I added 1 plus 10 plus 4, I wonder what that adds. Oh, I'm calling them.
You wonder what the sum is going to be, Omar?
Let me see. Hello?
Omar?
Yes.
Is this a free call?
Yes, this is. Is this Omar's mother?
This is Aunt.
Hi, Aunt. Yes, this is a free call. Omar actually did dial the number to the Prince George's County. This is the local station, so this is free. He's allowed to call us as long as you are in agreement with it, and we are here to help him with any homework questions he has.
Okay. He's watching it on TV. He doesn't even have any math homework today.
Well, that's okay.
But that's wonderful.
Omar can ask us this question, and we can talk about it. Okay?
Oh gosh, I'm looking at y'all right now.
Yeah. Yes. Hi, Aunt.
Hello.
Okay.
Hello.
Hey, Omar.
Hi, Omar.
Good.
Oh, okay. Omar, so your question is, what does this equal?
Yes.
Okay. What is the answer to an addition problem, Omar?
The answer is...
No. Don't tell us this answer yet. Do you know what the answer is called when you have an addition problem?
A math sentence?
Okay, well, this is a math
part of
sentence.
the math sentence,
Good job.
yes.
But the answer in this case is a sum, okay?
Okay.
So we're going to find the sum. When you're adding numbers, the answer is going to be the sum. But yes, you're right. We have part of the math sentence here, and then when we get the sum, we'll have a full number sentence, okay?
Okay.
All right, so tell us what you know about 1 plus 10.
1 plus 10 is 11.
You are so smart. Okay. Yes.
So you said 1 plus 10 is 11.
Closing. Uh-huh.
Okay. So we've already answered the 1 plus 10. Now we're going to do what? Add what? What number is this?
4.
Plus 4. So now we have 11 plus 4.
15.
11 plus 4 sounds good to me. So you can either do equals 15, or I'm thinking of the older students who may call in.
Yes. Mm-hmm.
And you'd have your 15 here. So since you're second grade, we'll go ahead and do it this way. So 11 plus 4. I think 15 is correct.
Yay.
I have a question for you, Omar.
Yes.
I'm going to write this again. 1 plus 10 plus 4. What if I added 1 plus 4 first?
1 plus 4 is 5.
Okay.
Good.
So if...
And
Mm-hmm.
5 plus 10 is, let me see. 5 plus 10 is, one second.
No problem. Oh, and there's a...
15.
It sure is 15.
Oh my goodness. How is that possible? We have 2 different ways. But what happened, Omar?
What happened was that, when you try not to add, you can think, like, you can just say, poof, I got the answer.
Yes, you can. And I like, you did this mentally, didn't you? You didn't use paper or pencil?
Nope.
Very good.
Good job.
But look, we did it 2 different ways. On the first try, we added 1 plus 10 and then added 4 and got 15. But what's so great about addition, we can go in any order. I know 1 plus 4 like that.
We can go in across, up and down.
We can go, yeah, we can go across, up and
Absolutely.
down. We could add the 10 and the 4 first. What's 10 plus 4?
10 plus 4 is 14 because 10 plus 4, like, say if I said 10 plus 4, 14 is part of the 10 family, so that's how you know.
Very good. And you see how fast you did that? That's why with addition, when we're adding nothing but addition, we can add in any order. And if we can add the numbers we know like this, like 10 plus 4 is in the teens family, so I know it's 14. And then one more is what?
4 plus what?
14 plus one more.
15.
Good job, Omar.
Wow, Omar, we did this 3 different ways. We took that one problem and did it 3 different ways.
Good job. And Omar, guess what? You said you're in second grade, right?
Yep.
Next year in third grade, when your teacher talks about the commutative property at the beginning of the year, you can say, guess what? I already know what that is because we just did the commutative property. As Mrs. Jenneret showed you, it doesn't matter when you have addition. It does not matter what you add first, okay? These are called, the numbers that we put together are called add-ins, so it doesn't matter which order you add them in because it's all the property of addition. And so it doesn't matter. We did 1 plus 10, and then we did 10 plus 4. We switched all the numbers around, but we still ended up with 15 as the sum, correct?
Yes, but
Okay.
when I get older, will y'all still be on television?
You mean next year?
Yes.
You know what? Let me ask our producers. I think they said yes.
Okay.
We should be here, Omar. We'll be here to answer your questions, okay?
Okay.
And let your aunt know that you can call in on Mondays and Wednesdays. So if you have any questions this Wednesday at the same time, you can call us. Now, Mrs. Jenneret and I may not be on Wednesday, but there will...
Because I got the card and it says 38 and it says only Mondays and Wednesdays.
Good job. So someone at school gave you that card,
Good
right?
job.
Okay, and you can definitely call on Mondays and Wednesdays. You may see some different people here to answer your questions, but we'll always be available, okay?
Okay.
All
Can we
right,
get your
Omar.
teacher's name? What's your teacher's name, Omar?
My math teacher?
Yes.
Miss Rosen.
Miss Logan.
Miss Logan.
So let's shout out to Miss Logan, because I bet you Miss Logan.
It's Miss Rosen.
Oh, I'm
Miss
sorry,
Rosen.
Miss Rosen.
My math teacher.
We'll make sure we write that down correctly, Aunt. Okay.
And thank you, Miss Rosen, for giving out those
Rosen.
cards. Oh,
Thank you.
you're welcome.
Thank you. Okay. And Omar's name is going to go in our treasure box. So we'll see if Omar is the winner at the end of the show.
Omar, did you want to try a challenge?
Huh?
Did you want to try a challenge? Oh, I hear myself.
He turned his television
Oh, my
back
goodness.
up.
Where is the talent?
Well, we have two challenges. Have you ever played 24? Oh my goodness, I'm so
24?
loud. It's a card game
Yes.
where you had to make 24 or call back and unscramble this word. This word may be a little, but maybe your aunt can help you.
Or someone else at home.
Mm-hmm.
Okay, Omar?
Uh-huh.
Okay.
So if you want to do the challenges, call us back, Omar.
Okay.
Okay.
Wait a second. My cousin wants to speak to you.
Oh.
Did your cousin have a question?
Hello?
Hi. Do you have a math question?
My cousins are very good. He's getting well at math, and so am I.
Oh,
Good job.
great.
Well, you continue to make sure you listen in the classroom, okay?
Okay.
All right, call us back
We
if you
both
have
in
any math
class,
questions.
So he's very good. He's getting very good.
Okay, good job.
All righty.
Thank
you
you.
for tuning in. All
Okay,
right. That was
so,
fun.
Yes, he's doing really well as a second grader. He knew how
Yes.
to add things, and he was able to do mental math. And he said, "You can just add it up, and poof, you get the answer."
Yes. And I wish it was like that for all math.
Yes,
But you know what? It can be poof if we use our strategies.
Absolutely.
And we
Did I erase
talking
what
about
we were?
fractions, but that's all right.
Did I erase
Oh,
it? Okay.
I remember what we were doing. We were looking at 1/4, the unit fraction, 1/4 and 1/8, and asking why is 1/4 larger or greater than 1/8 when 8 is bigger than 4.
Yeah, I wonder how that can happen. Okay.
So, I think what we were doing earlier, we
Comparing
were
it to
looking
one
at
whole.
the one whole and talking about partitioning our one whole. Our denominator lets us know how many parts to divide or partition. So 4 means we're going to have 4 equal parts.
Okay, so does that mean this one whole, if I were to cut it into 4 equal parts, one of the pieces would look like that?
Yes.
Okay. Okay.
So we are going to continue this wonderful conversation about our unit fractions, and we're going to answer that question. Why is 1/4 bigger than 1/8? So we will go to a break.
And we will see you on the other side of our break.
Hi, I'm James. I'm from Tilton Elementary School. I'm here today for the email question of the day. Mary needed to place a fence in her yard in order to keep her sheep in. If her yard is a rectangle with a length of 26 feet and a width of 20 feet, how much fencing will she need? Well, let's take a look. So first, I would draw a rectangle to represent her feet. Then I would draw 26 feet at one side and 26 feet on the opposite side. Then I would draw 20 feet at one and another side, and then 20 at the opposite side to represent the fencing. Since we're talking about perimeter, since I have to do perimeter, I have to add all the numbers. 26 plus 26 plus 20 plus 20. 6 plus 6 equals 12, so I'll put the 2 at the bottom and carry the 1. 2 plus 2 plus 2 plus 2 equals 8. Then I'll add the 1. That equals 92 feet. So the fencing of her yard will be 92 feet. That's it for the email question of the day. Stay tuned for some more on Count on Us.
Does retirement have to wait until my 70s? Is a great college for our kids?
Out of the question?
Is the American dream
Out of our reach? Not if we can help it. We're the National Endowment for Financial Education, a non-profit organization dedicated to helping people just like you get smart about their money. Log on to smartaboutmoney.org today and start taking control of your financial life.
He was so inspiring.
he took chances?
He was so moving.
He lived daringly?
Martin Luther King Jr. was a man of service, and his day shall be a day of service.
He inspired us in words, but he led us in deeds. To honor him, let's do the same. Go to mlkday.gov and find out how to volunteer on Martin Luther King Day and beyond. This message is brought to you by the Corporation for National and Community.
Okay, guys, ready? Here we go. Let's smile and brush our teeth twice a day, every day. Let's smile and floss our teeth once a day, every day. Let's keep that smile a happy place on your face with good nutrition and dental visits. Let's smile. Let's smile. Let's smile. Let's smile.
Welcome back to the second half of Count on Us. I am Mrs. Jax.
And I am Mrs. Jennerette.
We are here to answer any homework question you have. It doesn't even have to be a homework question. It could be something that your teacher discussed in math earlier today or even before the break. Maybe something that you're working on first in math, and maybe you're having some questions about it. So definitely call us with your questions.
Yes, the number is on the screen. Call us at 301-772-0800. And we are here for you. Any math question? We had a caller
right before the break. Yeah.
And he was us.
Second grader called. We had a good time with Omar.
Yes.
But it looks like we have another caller. So after we meet with our caller, we can talk about the challenges. Yes. If you're new to Count on Us, you call in, you ask us a question. Your name goes in the treasure box at the end of the show. We shake it up. We randomly pull out a name. And if your name is chosen, you win a prize. And the prize will get sent to your school. Okay? So I think we can dive right in with our next caller.
Hi, caller. What's your name?
Isaac Onyakwa.
Hello, Isaac.
Hello.
What school do you attend, Isaac?
CT Reed Elementary School.
CT Reed. Does that stand for Catherine?
Yeah, Catherine Reed.
Okay, what grade are you in?
The third grade.
Third grade. I think I know your teacher, but...
Miss Ben.
Okay, yes, I do.
Did you say Miss Ben?
Miss Ben.
Ben. Okay. All right.
All right, Isaac, what is your question?
A square. Square. Perimeter, I meant.
You want to find the perimeter?
Yeah.
All right. Is there a specific figure you want to find the perimeter of, or do you just want to talk about what perimeter is?
Write a square.
Find a square?
Yes.
Okay, Isaac, who's that helping you out? Someone's whispering information to you. Is that a sibling?
No. It's my mom frying something.
Oh, your mom's frying something. Okay. Okay. So, do you have any dimensions for this square?
30, 20, 30. Wait. Did you?
They're frying, really.
And no one's whispering.
Is it a square or is it a rectangle?
2/3 of... You guys move on my personal business.
Okay, Isaac.
Well, let's come focus.
Do you need to get your question together and call us back, or do you have it ready?
I need to call you guys back.
Okay. Thank you, Isaac. Okay, so callers, we welcome all types of phone calls about math, but just make sure you have the information ready because we are live on air and we do have people calling in, and we want to make sure that everyone gets a chance to ask their question on air. Okay. All right.
Should we review the
Absolutely.
challenges?
Yes, we should.
For those of you watching that have your homework question, after we answer your question, do a challenge. So our first challenge is 24 challenge. We have cards with digits on them. The object is to use addition, subtraction, multiplication, or division, a combination. The goal is to make 24. So we're going to read the numbers on the card, and then you're going to write them down and then call us when you want to tell us the answer. So card A, we have the digit 1, 5, 2, and 9. This is 9 because there's a red circle inside.
Okay, on card B, we have 3, 4, 7, 2.
Card C, we have 4, 2, 4, 6.
And card D, we have 7, 2, 5, 3.
So pick a card, tell us which card you want to use, and show us how we can get to 24.
Okay. Now, what is this? This is a word scramble? How does that work?
Well, this is our second challenge. These are our letters. You're going to unscramble the letters to come up with a mathematical term or vocabulary word. Okay. So whatever you unscramble, it has to be math related.
So you mean it's not gokrilim or whatever you said earlier?
It sure is not gokrilim or malapurkrim, because that's not a word. Okay. But it definitely has to be a mathematics vocabulary word. So those are our challenges, and we are going to continue and wrap up
with our
conversation.
Okay.
And then we're going to move on to my favorite. It's a 5th grade skill this year.
And what skill would that be?
Back in the day, we called it PEMDAS, the order of operations.
We used to say, please excuse my dear Aunt Sally. Have you ever heard of that?
I have. I had a student make up his own little, what was it?
Little saying?
I can't remember, but it had something to do with monkeys.
Oh, really?
Yes, it was cute. But let's go back to our fractions real quick, and I should have done this earlier. Because
do we have another piece?
Yes.
All right.
And
perfect.
We should have some more 8s.
All right, so we're going to put these 4ths together.
And there we go.
Match it up with the
live TV is so much fun.
It is.
So we have our first set of fractions, our unit fractions, 1/4. If we partition this one whole into 4 equal parts, our parts are larger because we have fewer parts we're partitioning.
Okay.
So our 8s, I'm going to put it above. Even though 8 is greater than 4, the number 8 is greater than 4, an 1/8 is less than a 1/4 because we're taking our one whole or our whole and we're partitioning it into 8 equal parts.
Okay, so the whole never changes, just the number of parts that or just the way you're partitioning it changes.
Exactly.
Okay, so that makes more sense.
So I wonder how many 8ths would equal one whole.
Well, if it takes 4 of the 4ths to equal one whole, 1, 2, 3, 4, then I would hope that it would take 8 8ths to equal one whole.
It absolutely does. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8.
Wow.
8/8 is the same as one whole.
Okay, so you mean, and Isaac, we see you. We're coming in just a moment. So you mean 8 8ths equals one whole, and 4 4ths also equals one whole?
Exactly.
Wow. So anytime the numerator and denominator have the same number, are you telling me that equals one whole piece?
It does, because that top number tells us how many parts, the bottom number how many total parts, 4 4ths, put them all together, is one whole.
Wait a minute. So what if I had something like 238 over 238. Would that still equal 1 whole?
It will. You would have the teeniest pieces because we would have to partition our whole into 238 equal pieces. But then when we take one of those pieces, that would be the unit fraction, 1 238ths. And then we add 238 of those, that will equal 1 whole.
Wow. Okay, something to think about. All right, so if the numerator and denominator are the same, it equals 1 whole. Okay. Isaac, are you ready for us now?
Hi, Isaac.
Hi.
Hi. Are you ready to ask your question on Count on Us?
Yes.
Okay. Is your question still dealing with perimeter?
Yes.
All right. What is your question?
Well, first put a square.
Okay, so we're going to talk about perimeter. Is that correct?
Yes.
Okay. Do you have any units? I'm sorry, not units. Do you have any dimensions for this square or any numbers that go on the square?
Yes.
Okay. What are those dimensions? What's the length and the width?
The length is 4. The width is 5.
Okay. For what? Is it 4 feet, 4 centimeters, 4 inches?
4 inches.
Okay. All right.
That's interesting.
Wait, you said it's a square. Okay. So this is going to be a rectangle. Please tell me how I know it's a rectangle.
It's because there's 3 parts to the question.
Okay. So Isaac, with a square, all of the sides have to have the same measurement. They all have to have an equal length. So if my length is 4 inches, then my width would also be 4 inches.
Oh, yeah.
Okay, so do you want to keep it this way or do you want it all to be 4? It's your choice.
All to be 4.
Okay, so that would make it a square. Now, we can still do a rectangle. We know a square is a special rectangle.
Yeah.
But we can do, you said no. Okay, you want to do this way. All right, so if this is 4 inches and this is 4 inches, what does this top have to measure?
That's to measure 30, 40, 30, 20.
Okay, Isaac, remember we talked about with a square, all of the sides have the same length? So,
oh, yeah.
Okay, so if this is 4, this is 4, this has to be what?
4.
4. Good job,
Good
Isaac.
job.
And what about this side, Isaac? That has to be what?
4.
4 inches.
All right, yes.
Okay, so what do you know about perimeter?
Perimeter is the opposite of area.
Okay, Isaac. Perimeter. Let's just talk about perimeter. We can compare it to area in just a moment. But do you know anything else about perimeter?
No.
Okay. So the perimeter is the distance around the figure. Okay?
Oh, yeah, I remember that.
Okay, so you remember that. All right. So it's not the opposite of area, but it can play a part with the area. So the perimeter is the distance around the figure. It's also going to be the distance around the area. Okay? But in this case, we're just looking for perimeter. Do you know what operation you're going to use to find the distance around this figure?
Yes.
Okay. So how can we find the perimeter, Isaac?
We can find the perimeter by doing L plus width plus L plus width.
Okay.
So we're going to add.
We're going to add 4 plus 4 plus 4 plus 4.
For what?
To find the perimeter.
To find the perimeter, we're going to add 4 inches plus 4 inches plus 4 inches plus 4 inches. And that'll tell us the total distance around the figure.
Yes.
So, what's 4 plus 4 plus 4 plus 4? Let's start here. 4 plus 4.
16.
Oh, so fast. How did you do that so fast? 16.
Because I know 4 times 4 equals 16.
Okay, so you see the 4 different times?
Yes.
Good job. So you know that 4 times 4 equals 16. Good job, Isaac.
And we could do that with finding the perimeter of a square. We could take the length and multiply it by the number of sides and still get 16 inches.
Yes, we could. Good
Okay.
job.
Now, you said you had a 3-part question?
No.
Oh, okay.
Okay, so I need to ask you, do you know anything about area?
Yeah.
Okay, tell me something about area.
Okay. How wide something is?
Well, let's talk about this. If we wanted to find the area of this square,
We will have to do 8 times length times width.
oh, so you've been listening in class. You need to let Miss Ben know that you've been doing a good job. So A, or area, equals length times width. Do you agree with that, Isaac?
Yes.
Okay. And I see Mrs. Generette went ahead and drew a model for you. So you can see that it's 4, 1, 2, 3, 4 units down and 1, 2, 3, 4 units across. And if we were to add all of these 1, 2, 3, 4, 5, instead of doing all of that, we can use the formula that you gave us, length times width. So you could just simply multiply the 4 times the 4. And you said that you already know 4 times 4 equals what?
4 times 4 16.
4 times 4 equals 16. Okay, but if you have a harder question in 3rd grade, which you surely will get something a little more difficult than this, just remember to multiply your length times your width, and it will give you the area. Okay?
Okay.
All right, did you want to add anything, Mrs. Generette?
I was just going to say this is one of those cool things where the perimeter and the area were the same. I wonder if that's true with all squares. Perhaps we can look at that another time because we do have another caller, but I wanted to make sure and find out from Isaac, did you want to try a challenge?
What kind of challenge is this?
Okay.
Well, we have a 24 challenge and we have a word scramble. We can show you quickly and then you can call back because we want to make sure we get to our next caller.
Okay.
Don't be... You can call back.
You have time, Isaac, okay?
Have you played 24?
No.
Well, with 24, you have 4 numbers, 4 digits, and you have to make the number 24. Either you add them, subtract them, multiply, divide, any combination, but the goal is to make 24. So we have 4 cards. A has 1, 5, 2, and 9.
B has 3, 4, 7, 2.
C has 4, 2, 4, 6.
And D has 7, 2, 5, 3.
I know the answer.
Okay, which card are you looking to?
The answer is C.
Oh, okay, so listen, this is what we're going to do, Isaac. Why don't you write down the numbers for C? Why don't you write down 4, 2, 4?
4.
Okay, Isaac, listen for one moment. Why don't you write down 4, 2, 4, 6, and then with those 4 numbers, why don't you try to add, divide, multiply, or divide? You have to use all 4 numbers and try to get 24 as your answer, okay?
Okay.
All right, and then call us back, okay, Isaac?
Okay.
Because we see Ashley's been waiting. She's on hold. She's been waiting. But guess what? Your name is right here. And your name will go into our treasure box.
Yay,
so
Isaac.
far we have 2 callers, and I guess Ashley will be our 3rd person in the treasure box. But call us back, okay, Isaac? Okay.
All right.
Hello, and welcome to Count on Us. Hello out there.
Hi.
Hi, how are you?
Good.
Welcome to Count on Us. What is your question today?
I need to find the perimeter.
Perimeter. And you know what, Ashley, I apologize. I was so excited to get another caller that I forgot to ask you what school you attend and what grade you're in and who your math teacher is. So Mrs. Generette is going to write down the information once you tell us. What school do you attend?
Glenarden Woods.
Glenarden
Elementary.
Woods. Okay. Who is your teacher?
Mr. Coons.
Mr. Coons? And what grade are you in, Ashley?
Second grade.
Second grade,
Oh,
okay.
wow,
You have an
okay.
area and perimeter question.
Yay.
Okay, so we're ready. What is your question?
I have a square that is three square units on the top,
Okay.
3 square units on the bottom, 3 square units on the side, and another 3 square units on the top.
Okay.
On the side. on the other
Definitely
side.
sounds like a square.
Yes.
Okay, so what is the
But
question?
in the middle, it's missing a square unit.
Okay. We're going to draw what you told us, and then you'll let us know if we have the drawing correct, okay?
Okay.
So you have,
So you said the one in the middle is missing?
Yes.
so let's...
On your paper, is it shaded? Like, is there
Shaded
a
in?
darkened spot, or let's just say this is the missing piece. So is this the piece on your paper that's missing?
Yes.
Okay. So the red means missing. This is for all our people in TV land. This is the missing piece. Okay. So what is the question?
What is the perimeter?
Oh, okay.
So, like, do you count the one in the middle, around the missing unit?
I'm so glad you asked
This
that.
is a fun question.
Because we definitely talked about perimeter with Isaac. And did you hear our definition of perimeter? Or did you
Yes.
hear? Okay. So do you remember what we said about finding perimeter, or what perimeter is?
I remember what perimeter is.
Okay. What is perimeter?
It is the length around an object or shape.
Okay.
Excellent.
All right. Good job.
So even though we have this missing piece, can we go around this way? How many units? What's the length?
3.
So we're going to have our 3, and then we're going to continue going around. How many units have we gone around in this direction?
3.
Good. And then we're going to mosey on to the left. How many units?
3.
Uh-huh. And then we're going to go to the top. So now we've gone completely around the figure. How many units have we traveled up?
12.
Well, we went another 3 units. So the total distance around the figure, even with this missing piece, we're still going around, is how many units?
You just said it, Ashley.
Yep. We wrote Miss Jax wrote the equation or number sentence.
3 plus 3 plus 3 plus 3, or 3 times 4.
Excellent.
You are so smart. Good job.
And that equals 12, like you said earlier. Now, this missing piece would affect what? What do you think this missing piece will affect? The perimeter, it didn't affect the perimeter because we are still going around this shape.
So it'll just affect the area.
Good job.
Now, why would it affect the area? What is area?
It's the measure inside a shape or object.
Excellent. The units inside the shape or object. So if this piece is missing, how many square units are inside this figure?
9.
There's 9 including this piece, but if this piece is missing,
8.
There would be
Very
8.
good.
job,
The
Ashley.
area would be 8 square units. So that's a really cool question because you would think if it's missing, it's going to affect something, but the perimeter it won't affect because perimeter is around the figure. It would affect the area because the number of square units inside the figure will be less.
Mhm.
Okay, does that make sense, Ashley?
Yes.
All right. So, Ashley, would you like to try a challenge?
Yes.
All right. And we do see students on hold. Ashley is probably going to be our last caller, but guess what? There's another show coming on directly after this. It is the middle school show, and those teachers are fabulous. They will definitely answer your questions. So just hold on, okay? We're going to continue. Don't hang up. Hold on. Hold your place in line. Okay, so Ashley, which challenge would you like to try? We have 24 and we have word scramble. Which one would you like to do?
I want to see those first.
I'm sorry?
I want to see them first.
Oh, you want to see them first. Okay. Well, this is 24. Do you know how this works?
Huh?
Okay. For 24, you need to choose one of the cards. You need to use all 4 numbers to come up with 24. You can add, subtract, multiply, or divide all 4 numbers and end up with the number 24. Or you can try the word scramble and unscramble these letters to come up with a math word. Okay?
Okay.
Okay, so which one do you think you want to do?
The numbers.
Okay, the 24. So which card would you like to try?
A.
A.
Card A.
Okay. So you need to write your numbers down.
I'm going to write them here.
The numbers are 1, 5, 2, and 9. You have her name.
Huh?
All right, so what can we do with these numbers to make the number 24? Remember, you can add, multiply, divide, or subtract. Okay, or you can try it. I mean, I don't know if you can try it and then call back on the next show. I'm not sure how this will work, but we only have a few minutes. So if you want to try it, we can try to work through it with you, or you can call back on Wednesday and we can try 24 at that time. Would you like to do that?
Yes.
Oh, I think you said yes.
Did she say yes?
Mm-hmm.
Okay. So
all right, Ashley.
I'm going to call you back.
You going to call us back? Well, yes, call back. Either our next team will be here at 5 o'clock on the next show, and call back with your answer. Okay, Ashley?
Okay.
And we did put your name in the treasure box for calling with that homework problem. And
it looks like you have a lot of friends calling from Glen Arden Woods. We have a lot of people on hold.
Did you call everybody and say call?
Okay, so unfortunately we are nearing the end of our show. This is a tough place to be in. We have
got like a minute left.
4 or 5 people on hold, and we only have a minute left. Not long enough to talk to anyone and get their questions answered. But stay on hold. We see Rose, Andrew, and Geraldine. Please stay on hold because our fabulous counterparts will be on for the middle school show. Remember, we are on Mondays and Wednesdays from 4 to 5 for elementary, 5 to 6 for middle school. You can call us if you have any questions. We're here to answer your questions. You can always email us. So those of you who may not get a chance to go on tonight, email us. And remember the email that I almost fumbled. Well, I did fumble it in the beginning of the show. The email is COU for Count on Us at PGCPS.org. Write your question in an email. Send it to us, and it will be answered on the show during the break. So it looks like we have just enough time to choose
Pick our name
out of our treasure box. We're going to shake it up. Shake it up. Okay. So we're going to quickly choose someone.
I almost missed the box. And the lucky person is Omar. For Allenwood Elementary School. We got
Omar was our first caller. All right, Omar, you get the cowbell. You get the... Okay.
You got 2. Yay.
Thank you for your calls today.
Callers, stay on the line.
Yes, and remember, anytime you have math questions, you can always count on us.
name is Mrs. Sun, and I'm here with today's mini lesson on area. Very often people learn about perimeter and area at the same time. So I want to talk to you about what area is and the difference between the two. Our objective today is to apply measurement concepts in order to determine area. Area is the number of square units inside a shape. So we are looking at the inside of a shape. So very often you're going to look for keywords in word problems. Sometimes people are talking about finding carpet for a room or tile for a floor. Look for those keywords where the word problem is talking about covering the inside of a shape, because often they won't say find the area. They will say how much carpet is needed, or how much tile is needed, or how much paper to cover. That would be another keyword, a bulletin board. So look for those keywords, and we're going to talk about how to find area in a moment. There are a few different ways. Let's take a look at word problem number 1. Melanie wants new carpeting. There we go. There's that keyword for her family room. Her family room is 8 feet by 4 feet. How much carpeting does she need to cover the room? Anytime there's a word problem and you don't see the shape, go ahead and draw that shape. So I'm going to draw a rectangle here. It's not going to be the prettiest rectangle, but it's going to work. And we're going to label that. We know it is 8 feet by 4 feet. Now, in order to find the square units inside, we often multiply to find the area, and that will work, but I want to explain why that works. When we are multiplying to find the area, 8 times 4, what we're doing is 8 groups of 4. So what we're really doing is we're really building an array inside of this shape. So we would break this up into 8 groups. Okay, that's 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. They're not equal, but pretend they are. And then here we would have 4 groups. So what we are doing when we are multiplying is we are building rows and columns of equal groups to build an array for 8 times 4. So if we counted that out, we would know that that would equal 32 square units. Since we know it's feet, that's 32 square feet. Anytime we're talking about area, we want to talk about the square units because we are building those square units inside of a shape when we multiply. So to find the area of a rectangle or a square, I want you to multiply, but the reason is you are building that array inside. If you are finding perimeter, I want to talk real quickly about the difference. Perimeter would be the distance around. So it would be 8 plus 4 plus another 8 over here plus another 4 over there. But that's another mini lesson for another day. Let's take a look at one other problem. I really like this problem. This is from mdk12.org. Nathan divided his rectangular garden into 8 sections that are the same size and shape. What is the area of the whole shape? So this side right here says 4 feet, and this says 7 feet. So there are a few different things we could do. If we want to multiply length times width, we could find the length and the width of the whole thing. If this section is 4 feet, this section is 4 feet, so this whole thing would be 8 feet. If this is 7, and we know that this is a rectangle, then this is 7, and this is 7. So this whole thing would be 14 feet. So we found the whole length and the whole width by using what we know about these rectangles right here. So we could multiply the length times the width, 14 times 8. 8 times 4 is 32. 8 times 1 is 8. Plus 3 more is 11. So it would be 112, remember, square feet. Okay? Now, we could also find the area of this rectangle right here by doing this rectangle right here would be 4 times 7, because that's length times width, which is 28, and then 4 of these exact rectangles. So 28 times 4 would be 8, and 3 more would get you the same answer, okay, square feet. But I like to find the length and the width of the whole rectangle. Otherwise, be careful, because 7 times 4, 28, was the area of this whole rectangle, and that whole rectangle happens 4 times. So be very careful of word problems, but remember, for rectangles and square, length times width. If you're not sure, you can always remember ma and pa, multiply area, perimeter, add. That will help you remember the difference. So, my name is Mrs. Sun. That was today's mini lesson on area, and I hope you have a wonderful day.
Minds can achieve anything. We make sure they get to college. Federal student aid provides more than $150 billion in grants, loans, and work-study funds to make college possible for anyone with the mind to get there. Because if given the chance, minds will do great things. Federal Student Aid, proud sponsor of the American Mind. Learn more about money for college at studentaid.gov.
Because how many ways are there to solve math?
Many! Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, I need you to double check yourself. So the second equation for solving perimeter is?
2 times length plus 2 times width.
And welcome back to the second half of our show. It's the secondary edition of Count on Us. I'm your co-host, Mr. Pugh.
And Ms. McCants.
We're here to help you with your math questions for today, getting close to MSA, HSA, and all that good stuff is coming up around the coming months and weeks. And so, we're here to answer all your questions to serve you, our students of our county. As you know, we always have several challenges for the show today. Mm-hmm. We're going to carry over the word scramble from the earlier show. So you just want to give a quick glance at the word scramble. Yeah, as soon as our producer pushed the button, yes. Yes. So I'm going to give you a hint. Think about measurement. Think about measurement. I give you a hint. Measurement. That's our word scramble for today.
Okay.
And Ms. McCants, can you please just talk about the Challenge 24?
I can definitely talk about the Challenge 24
awesome.
Or the 24 Challenge.
Yes.
And the goal of the 24 Challenge is to use any combination of the numbers with multiplication, division, addition, or subtraction as our operations to come up with the number 24. So I'm going to start with card A. That's a 9, 4, 8, 5. Would you like to do card B, Mr. Pugh?
Card B, yes. 3, 3, 7, 8.
Card C is 7, 8, 2, 4. And card D, I'll do that for you.
Oh, thanks so much.
7, awesome. 7, 4, and 3. And they say that the card with 3 dots is the most challenging, but, depends on if you like a challenge or not. But the other cards are medium to hard.
Yes, I see medium to hard, yes.
Okay, and that's 24 challenge. So write down a card that you would like, those numbers, and we'll try to work it out and give us a call in.
And remember, you must ask a question before doing the challenge.
Yes.
So you must ask a question before doing the challenge. I get so nervous when I work with Miss McCarthy. She's such an awesome teacher. So Miss McCarthy, let's go to our first call of the day.
I'm ready.
All
if
right.
you're ready.
She's an awesome teacher, awesome person.
So who do we have on the call for first? Who's on first?
I believe it's Rose.
Rose.
Rose,
are you there?
Yes.
Hi, Rose.
Hi.
What school do you go to?
Catherine T. Reed Elementary School.
Okay, Catherine T. Reed. So who's your teacher there?
Miss Martin.
Miss Martin.
Uh-huh.
Well, tell your teacher and all of your friends at Catherine T. Reed we said hello, okay?
Okay.
What's your question?
I have a question. My question is 2/8 times 4/5.
Oh, I love the way you said those fractions. 2/8
2/8
times 4/5
times 4/5.
Wow.
Okay. So what do you know about multiplying fractions, Rose?
We're going to have to multiply the numerator times the numerator and the denominator times the denominator.
Excellent job. You are going to have to multiply the numerator times the numerator and denominator times denominator. So we have 2 times 4.
It's 8.
Is 8.
Uh-huh.
And we have 8 times 5.
40.
Which is 40. Now, we could have cross-simplified first. And I'm not sure if your teacher, Miss Martin, showed you this method. It's where we cross-simplify. We cross out the 8 and the 4, and we find one number that can go into both 4 and 8.
2. Wait,
2.
no.
2 is a good number, but is there another number that's a little bit bigger than 2 that we can use to go into 4 and 8?
No, 4 can go into both of them.
That's right. 4 can go into both of them. So that means if 4 divides into 4, that can go 1 time, and 4 can go into 8. How many times?
You said, can you please repeat that?
How many times can 4 go into 8?
32.
How many times does 4 divide into 8?
Oh, 4.
There you go. Good.
4
No.
goes into 8 2 times, right?
Yes.
Okay, so here I'm simplifying before I actually do the multiplication of numerators and denominators. So I won't have to simplify on the end. So if I have 2 times 1, how much is that?
You said?
2 times 1?
2 times 1?
Mm-hmm.
It's 2.
It's 2. And if I have 2 times 5, how much does that equal?
10.
10.
Mm-hmm.
Okay. Can I simplify 2/10?
Yes.
What will go into 2/10?
2.
2 will go into 2 how many times?
1.
1 time. And 2 will go into 5 how many times?
5.
I'm sorry. 2 will go into 10 5 times. Excellent job. So 1/5 should be your final answer. If we go back to 8/40ths, we'll see that 8 divides into 8 and 40 1 time, and 5 as your denominator. So we have the same answer. 1/5 should be your final answer. Did you want to try the challenge?
I would try to scramble.
You would like to try the scramble. Now, Mr. Pugh gave us a hint, and he said it had to do with measurement. Correct, Mr. Pugh?
Yes, ma'am.
Okay, so what's your guess?
Kilogram.
Ring that bell. Rose.
They're not going to show us ringing the bell, but it's okay.
Rose, you are a smarty pants.
So, Rose.
Kilogram. I didn't even know that.
So, Rose, your name goes into our
treasure chest.
Not once, but twice.
2 times. Congratulations, Rose. And stick around to the end of the show to find out if you are our winner for the day. Okay?
Okay.
All right. Have a good night.
All right. Good job.
Yeah, I'm so impressed. Wow. So now all we have left is the 24 challenge.
Mm-hmm.
So who's next on the line?
Geraldine. Geraldine, how can I help you?
Hello?
Hi, Geraldine.
Hello?
Geraldine?
Oh, yes, sorry.
You okay? How you doing?
Okay, I have a question.
Okay.
And it's about multiplying mixed numbers.
Okay. So can you write this down for me, please? So what's your question?
Okay. The question is 1 3/8.
1 3/8
times 2 2/7.
times 2 and 2 7s.
So Geraldine, so we multiply mixed numbers, correct?
Yes.
So what's the first thing I must do with my mixed number? My mixed number.
So you can't times mixed numbers, so you have to turn the mixed numbers into improper fractions.
Excellent
So
job.
tell me, what would 1 and 3/8 be turned into?
Okay, 8 times 1 equals 8, plus 3 equals 11.
Good.
So 11 over 8.
Thank you so much. And 2 and 2 7s would transform into what?
2 times 7 equals 14. 14 plus 2 equals 16 over 7.
Okay. Whoa, these are some big numbers, aren't they?
Oh, we can do simplify before you multiply.
So talk to me. How can I simplify before I multiply?
8 and 16.
Okay.
8 can go into 8 one time.
Okay.
So you cross it out and make it a 1.
Okay.
And 16 can go in. 8 can go into 16 two times.
Okay.
So you cross it out and put a 2.
Okay. So what do I do next?
And then, okay, you can't do simplify for 11 and 7. So 7 times 1 is 7.
Okay.
And 11 times 2 is 22.
Okay. Now, what's the problem with this fraction?
It's an improper fraction, so you have to turn it into a mixed number.
Now, before you turn this to a mixed number, I'm going to give you a hint right now, okay? I know you can. What grade are you in, Geraldine?
Okay, 7.
You in 7th grade?
Huh?
What grade are you in?
Geraldine.
I'm in 4th.
Okay, now watch this, Geraldine, because you sound like you're a real mathematician. So all the vocabulary you're using, how you breaking this question down, because I hardly said any words. I didn't say anything. You've been doing all the talking. I like that, okay?
He loves that.
But watch this, Geraldine. Watch this, Geraldine. The fraction 22 over 7 reminds me of something else. Because what you don't know, 22 over 7 is pi. That number would never repeat itself. It never end. 22 over 7 is actually something called pi. P-I. So what I want you to do is look that up one day, okay? So we're gonna round this to the nearest 100, okay? Or mixed fraction, okay? Hello?
Geraldine. Okay.
All right. So let's go back. So tell me how we change this improper fraction to a mixed number. Try to give it extra information there.
We turn this improper fraction into a mixed number by 7 goes into 22 3 whole times.
3 whole
would
times.
be your whole number.
That's right.
And 1 is left over, so 1 would be your numerator.
Uh-huh.
And 7 is the denominator. It stays the same.
Hey, Geraldine, thank you so much for teaching me this problem, okay?
Okay.
Because you taught me. I didn't know how to solve, multiply mixed numbers.
Okay.
You're awesome. I'm going to put your name in our treasure chest. And did you want to try 24 challenge?
Yes.
Oh,
Okay.
wow.
Excellent
Go
job.
ahead.
Geraldine, did you already copy down the card that you would like to try?
No.
Okay, can you look at the cards and write down the numbers that you would like to try and then give us a call back, because we have a lot of people on hold trying to get through.
Okay, I would like to do the last one, D.
Card
D. That's a tough
7,
one.
3, and 4.
That's a tough one.
Call us back.
Yes.
Call us back with 7, 7, 3, and 4 solution for 24. You have to get 24, okay?
Okay.
All right. Talk to you in a
Bye.
few minutes.
I like those type of calls.
Me too.
I don't have to talk at all.
I see. You were doing no talking at all.
I like that. They told you always have to facilitate. They just give you all the
Okay,
learn.
let's try it. Who's next
Oh,
on
my
the
Lord. She's
Who's
trying to
next
cut
on
me
the
off my
line?
hair.
Who's next on the line?
Why am I here?
Emmanuel, are you there?
Yes.
Hi, Emmanuel. What school are you calling from?
Huh?
What school are you calling from?
Glen Arden Woods.
Glen Arden Woods. Who's your teacher there?
My math teacher or homeroom?
Your math teacher.
Miss Harding.
Tell Miss Harding we said hello from Count on Us, okay?
Okay.
What's your question?
It says, draw one segment that is both 1 and 1/4 inches long to the nearest 1/4 inch and 1 and 1/8 inches long to the nearest 1/8 inch.
That's a lot of questions. I'm glad she took that question.
Okay, so read it to me again really slow. You have to draw a segment. That's how much?
Both 1 and 1/4 inches long.
1 and 1/4 inches long. Uh-huh.
And 1 and 1/8 inches long.
1 and 1/8 inches long.
Yes.
Okay. And what else do you have to do with that?
Yeah. For the segment that is 1 and 1/4 inches long, it says draw one segment that is both 1 and 1/4 inches long to the nearest 1/4 inch.
Okay, so you have to actually draw this using a ruler?
Yes.
Do you have a ruler in front of you?
I have a ruler.
You do?
Yes.
Okay, I'm going to have to find my ruler. Okay, great. I found my ruler. So what I'm going to do, thank you, Mr. Pugh. He actually found it for me. So what we're going to do is I'm going to start over, okay?
Okay.
So you have your ruler in front of you. Do you have the inch aside?
Yes. I'm getting my ruler now.
Okay. So while you're getting your ruler, I want you to think about the inch side, and I think the other side should be centimeters or millimeters.
Okay.
Okay.
I got my ruler.
Okay, excellent job. So now you're going to have your ruler. You're going to look for the side with the inches.
Okay.
Okay. So you're going to, you have it turned to the inch side?
Do I have a what?
Do you have your ruler turned where it's inches?
Yes.
Okay, so if you're looking at the television screen, I have my ruler set to the inch side as well. Okay? So what we're going to do is we're going to look at from 0 to 1. It's already broken up into 4 parts, and that would be your quarters because they actually do 1 and 1/4 of an inch, right?
Yes.
Okay. What grade are you in, Emmanuel?
4th grade.
You're in the 4th grade. Okay. So what we're going to do is we're going to count from the 1, and I'm not sure what kind of ruler you have, but you're going to start at the 1.
Yes.
And then you're going to move over to the 4th part. I don't know. I can't see. I don't know which ruler you're using. Can we use that ruler too?
It's right here.
Mm-hmm. If you have a ruler like the orange one that I have here, how many little dots are there between the 0 and the 1?
16.
That's right. You're looking at the 16. So if I have 1 and 1/4, I'm going to look halfway through. That would be 1 and 1/2. Does that make sense?
Yes.
Okay, so go back 8. Go back 8. And that should be 1 and 1/4 there. So you're going to go from the edge of the ruler to that mark, and that should measure 1 and 1/4. So you're going to put your end point and your other end point.
Okay.
So that would be 1 and 1/4, and make sure you label it 1 and 1/4 inch using your units.
Okay.
Okay. Now your 1 and 1/8 is going to be smaller than your 1 and 1/4. Okay?
Okay.
So you're going to do the same thing. You're going to find the 1 inch. And you're going to count 8.
1/8.
We're doing 1 and 1/8. So it would be, if this is 1/2, this is 1/4, then it would be how many in there between?
I think like 2. There's 1/8 right here. There's a 1/4. So it makes 2 1/8 to make 1/4.
So you would find half of the 4th. You remember we just measured the 1 and 1/4?
Yes.
So do half of the 4th. So go past the 1 find the 1/4, and halfway between the 1 and the 1/4 would be your 1 1/8.
Okay.
Okay, and you're going to do the same thing. You're going to make your end point. After you draw your line segment, you're going to make sure you put your end points, and then you're going to label 1 1/8 inch.
Okay.
Okay. Was that it?
Yes.
Okay. Did you want to try a challenge?
Yes.
Okay, which challenge would you like to try?
D.
D? Okay, so let me move this out of the way. And we're going to bring up card D for you. Card D is 7734. Did you already work this one out?
Yes.
You did?
Okay.
All right, Emmanuel, you coming with your A game today. So you chose 7, 7, 3, and 4, correct?
Yes.
Okay, so what did you do with them?
So 7 times 3 equals 21.
Mm-hmm.
And then 7 minus 4 equals 3.
Mm-hmm.
And then 3.
Go ahead, I'm listening, I'm sorry.
And 3 plus 21 equals 24.
24.
Jingle bell, jingle bell, jingle bell rock. Good job, Emmanuel. Good job. Good job.
Emmanuel, you are a superstar. Excellent job. I couldn't even figure that one out. And you know what? Someone else said they were going to call back and try this one. But when they call back, they cannot use the method that you chose to solve for this 24 challenge, okay?
And your name going to chest not once, but twice.
2 times. Thank you so much for calling. And make sure your friends call us next week, okay? And even on Wednesday. We'll be here on Wednesday.
And continue to watch the show. You might have another question later on as you do your math homework.
And make sure you listen to the end so he can find out if he was the winner.
Of course.
Okay?
Of course.
Okay. All right. Thank you.
Let's get one more name before the commercial break.
Okay. Who we got?
David, are you there?
Hello.
Hi, David.
Hi.
How you doing? What school do you attend? What school do you go to, David?
Kenmore Middle School.
Oh, right across the street.
Kenmore representing. What's your question, David?
3 8 plus 7 9.
Uh-oh. 3 8. David, somebody on the phone with you?
No.
Okay. 3 8 plus 7 9. What must I do, David? What is the rule for adding fractions?
Make the denominator.
Hello? David? David. I think we lost David, but I'm going to solve it for you anyway, David, okay? I think he's going to say make the denominators the same, which we did. It was a great job. I can find my least common denominator between 9 and 8. Let me see, 18, 27, 36.
72.
I'm going to say 72. That's easier for me. So what did I do to the 9 to get 72? I multiplied it by 8. What I do downstairs in the denominator, I must do upstairs in my numerator, which is 56. 7 times 8. 8 times 9 gave me 72. So 9 times 3 gives me 27. So I know in my answer, my denominator is going to be 72. 27 plus 56 is 83. So I got 83 over 72, which is an improper fraction. So I must divide 72 going to 83 one time with a remainder of 11 over 72. And my answer, David, is 1 and 1172. And I think you were going to solve it the exact same way, David.
I really believe
Unfortunately, you must push the wrong button on your TV because this is live TV.
Yes.
So we can't wait for you. I'm so sorry.
And if you wanted to try the challenge, David, just give us a call
back.
Okay?
And I'm going to put your name in the chest anyway. We have Blessing from Ernest Just, Natalia from Ernest Just, and Olivia from St. Mary's. We're going to get right back with you in a few minutes after the commercial break. We have to take out a commercial break. And we see you after the break. Stay on the line.
is Shayla Tucker from Stephen Decatur Middle School from 6th grade. I'm here with your email corner for today. Here's our problem. Judy has 8 candy bars. She wants to give 1/3 of a candy bar to everyone in her class. Does she have enough for all 24 students? We already have our diagram divided into 3 pieces, so now we can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have 24 pieces. And now for our numerical expression, we have the total of candy bars, which is 8, divided by the parts that are shared, which is 1/3. So we make our fraction, which is 8 divided by 1/3. Now we have to find the reciprocal, and we have to change 8 to 8 over 1 because we have to make this a fraction, times 3 over 1 because that's our reciprocal, which equals 8 times 3, which is 24, and 1 times 1 is 1. So our solution is she has enough for all 24 students to have a piece. My name is Shayla from Stephen Decatur Middle School with our email corner for today. See you next time.
Can you tell?
Can you tell?
Does it look like I'm fighting a disease?
Fighting.
Fighting for my life.
Like my life expectancy is shorter than yours?
There's no outward sign.
But we're battling every day.
Every day.
Every day.
Worrying, testing,
Treating.
Fighting.
Fighting. Diabetes.
Diabetes has been called a silent epidemic. It's time to call it out for what it is. This is Brett Michaels. Join us. Choose to share, act, learn, and give. Help us stop diabetes.
When I was a kid, I dreamed of being a stuntman.
I went from dream to dream pretty quickly.
I wanted to be a cowboy.
Tom Cruise in Top Gun.
I dreamt of being a nun.
Actually, before that, it was Popeye.
Malaria kills more than 2,000 children a day.
Text NET, N-E-T, to 85944 to make a $10 donation to Malaria No More.
Oh, messaging and data rates may apply.
Let's make malaria no more.
And welcome back to the second half of the secondary Count on Us show. I'm Miss McCants, and I'm here with my co-host, Mr.
Pew.
And we are happy to have you back. We're going to start with our 24 challenge cards as a reminder of what we discussed the first half. This is card A, 9, 4, 8, and 5.
Card B, 3, 3, 7, 8.
Card C, 7, 4, 2, 8.
And card D, 3, 4, 7, 7.
And we've already had one caller call in and solve card D, but that does not mean that you cannot call in with a different method of solving using addition, subtraction, multiplication, and division. So you want to go ahead and just jump right back into those calls, Mr. Pugh?
Oh, yes, it's quite a few, yes.
Yes. So who do we have on air now?
Did we lose Blessing?
Nope, she's there. But Natalia, are you there?
Yeah, I'm here.
Hi, Natalia.
Hey.
What school do you go to?
Ernest Everett Justice.
Hey, E. Justice in the building.
I'm going to ring the bell for you all anyway. He doesn't get this kind of attention often, so I'm going to help him out. What's your question?
2x to the second power.
2x to the second power.
Times 5.
Times 5.
Minus y.
Is this in parentheses? Is this in the quantity?
I'm trying to simplify like terms.
Okay, so am I writing this correctly? 2x squared times 5.
Minus y.
Minus y.
Natalia.
Yeah.
When you say times 5, is it a dot or parentheses?
I'm sorry, what?
Is there a multiplication symbol? Dot?
Is it the raised dot that's in the middle up here?
There's a dot.
Okay.
Okay. I'm sorry. So you said 2x squared times 5 minus y.
Yes, and that's it.
And that's it? And you're combining like terms?
Yeah.
That's your question?
Mm-hmm.
Okay. Do you see any like terms in that question, in that expression? Let's talk about what terms are. What's your constant? Constant is a number. Go ahead.
A number without a variable.
So what's my constant in that expression?
5.
5. Good. Now, how many variables do you see?
How many what?
Variables. How many variables are there?
2.
Identify them, please.
X and Y.
Mm-hmm.
Good.
So we're going to do this triangles and circles?
You can be like, I used to do my taught, yes.
Okay, I'm just trying to be consistent.
Yes, you may.
Okay.
Yes, you may.
So triangles are for the constants?
Yes. And let's use a square for the y.
Mm-hmm.
And let's use a circle for the x. Now, are you watching your TV screen, Natalia? Are you watching TV?
I'm sorry, there's bad reception here. I can rarely hear you.
Okay, maybe it's me.
It's not you.
I'm going to let Miss McCann speak to you.
She's saying, he's saying, can you hear him? Do we have this correctly? Are you looking at the TV?
Yeah.
Okay.
So do you see our shapes? Do you see our shapes?
Can you see the shapes, the circle around the x, the 2x squared, the triangle around the 5, and the square around the negative y?
Okay.
Okay.
Are any shapes the same?
Do we have any of the same shapes?
Yeah.
How about that? That's all.
More than once. Do we have it more than once? Like, do we have 2 circles, or do we have 2 triangles, or 2 squares? Natalia?
I'm here.
I'm sorry. Did you hear my question?
You sound very scratchy. Let me try.
Maybe it's not me.
I said it wasn't.
Okay. Natalia.
Yeah.
Now, if you look at the TV screen, do you have any of the same shapes on the TV screen? Do you have another circle? You have 2 circles or 2 triangles or 2 squares? Or you just have 1 circle, 1 triangle, 1 square?
I still can't hear you.
Oh, okay. So he's asking. Okay. Well, you want to finish this? I think we lost her.
Yeah. So what we're gonna do is this: the expression is already simplified because we have no like terms in this expression. Because I don't see another x squared. I don't see another constant. I don't see another y by itself.
And so Natalia, what he's saying is, it's already simplified. There isn't anything else to combine.
No, you can't break it down no further than that.
So this is your final answer.
And what I might do is rearrange the problem to 2x squared.
2x squared
minus y
times 5.
I might do that.
That's what I would do too.
All righty then.
So Natalia, this is your final answer. If you're sitting there watching us, this is what you should have on your paper.
All right.
Okay.
Thank you. Peace out.
Next. Who's next? Uh-oh, Ernesty Just.
No, I think it's Olivia.
Olivia?
Oh, hello? Hello?
Olivia?
Hello? Oh, Blessing. Blessing?
Yes.
Hi, Blessing.
I told you.
You were right.
It was his fault. Blessing. It wasn't my fault. I could read.
She just threw me under the bus.
I could read. What was your question today, Blessing?
3x plus 4 minus 7x minus 6.
3x plus 4.
3x plus 4 minus 7.
7x minus 6.
Minus 6. Now, if
this is something we can...
This we can work with. If Natalia, if you're still watching, watch this problem, okay?
You ready?
You ready? You want to do it?
Yeah, I think I'm going to do this one.
Okay, you awesome. Go ahead. I'm going to sit over here and be quiet. I'm going to sit over here and be quiet.
So what we're going to do is look at the terms that look alike. Now, Mr. Pugh gave us triangles, squares, and circles. So for our constants, what should we put around the constants?
3x, circle that.
You want to circle this one, okay?
And 7x.
Is it 7x or negative 7x?
Negative 7x.
Okay, Blessing, do you mind turning your TV all the way down or putting it on mute and you talking directly to me in the television? I'm sorry, into the telephone?
Okay.
Okay. All right, so I have two circles around 3x and negative 7x. Now what should I put for 4 and negative 6?
A rectangle for positive 4.
A rectangle, or we can put a square.
Yeah.
Okay, put a square. So what about for the negative 6?
And a triangle.
Well, are these both constants? So we're going to use the same thing for the constants. So
Yes.
if you use a square here, then we can use a square here.
Okay.
Okay? Because we want to put these together. We are combining like terms, correct?
Yes.
Okay. So now, what is 3x minus 7x?
4x.
Okay. Is that going to be a positive 4x or a negative 4x?
A negative 4x.
A negative 4x, and that's because this is larger, right? We're remembering our rules for integers?
Yes.
Okay, so now I have a negative 4x. What am I going to do with 4 plus a negative 6? Or I could say 4 minus 6.
Subtract it.
Okay, we're going to subtract, and what are we going to have?
2.
2. Now, is this a negative or a positive 2?
Negative 2.
A negative 2. So we're going to rewrite this using what we have left over, okay? So I have negative 4x minus 2. Mm-hmm.
Yes.
Did you check behind Miss McCants to make sure that she did this correctly? Is this what you got on your paper before you called us?
Yes.
Excellent job. So Miss McCants followed all of the rules correctly, and she came up with negative 4x minus 2. Did you want to try one of the challenges, Blessing?
Yes.
Yes? Okay, great. So here we are.
And bless them, I'm putting your name inside our chest right now.
All right, so here's the challenge. Which challenge would you like to use? A, B, C, or D. Did you already work any out?
D.
Card B as in boy?
D.
D. Okay, so did you already work it out?
No.
Okay, well, write down the numbers and then give us a call back.
Okay.
Okay?
All right.
It was nice talking to you. And tell your friends at EE Just that we said hello from Count on Us, okay?
Okay.
All right. Talk to you soon. All right, I think it is now Olivia. Olivia, are you there?
Olivia?
Hello.
Hi, Olivia. How you doing?
Good.
How can we help you, Olivia?
What'd you say?
How can we help you?
I need help finding the loss.
Okay, give me your question.
Okay, it says the cost is $196.
$196.
And the rate of loss is 33 1/3%.
So you lost 100. So you need to find how much it costs after you lost your 33 1/3%.
I think I have to find out how much they lost.
Okay.
Okay, so the cost was $196 at a rate of 33 1/3%.
Yes.
So did they give you period of time?
Can you repeat that, please?
Did they give you a period of time?
A period of time? No.
Okay.
No. You just want to find out what would be the cost of the whatever item cost after 33% off.
It says I have to use this formula, L equals C times R.
arrow equals C times R.
I think it said L.
No, L.
L.
Loss equals
the cost times the rate.
Yeah.
Okay.
So you multiply. So can we multiply 33 1/3 times 196?
Well, I thought first my teacher said you have to turn 33 1/3 into
8%.
A decimal.
A decimal, geez, yes. A decimal?
You're right. I know
Yes.
that's what you meant.
Hello?
Yes.
She said, an improper fraction?
Yes.
Okay.
So that's the way you learn as an improper fraction?
Or as a decimal.
Or as a decimal. Which way are you feel most comfortable?
An improper fraction.
Okay, let's do that. So that becomes 100 over what? 3, correct?
Can you repeat that?
So what would that become? 100 over 3?
Yes.
But that's still that's still the percent, isn't it? You know what, Olivia, we're gonna do it another way, okay? I'm gonna show you a different way, okay? Okay?
Okay.
We're gonna change it to a decimal, okay? So I'm gonna change that to 33 3/10. Okay? And then I'm gonna move my decimal point 2 times to the left, where it gives me 333 thousandths. Okay?
Okay.
Hey, watch the TV screen. She's changing it right now to 333 thousandths for me. All right? So that's, in layman's terms, that's 0.333. Hope my producers don't get upset with me for saying that, okay? So I'm going to take that and I'm going to multiply that by $196. And I hear myself talking in the background. I sound so nice. So I'm going to cheat. Olivia. I'm going to take my calculator and multiply, okay? So I'm going to take my calculator and I'm going to multiply because it's kind of a big number. So I'm going to cheat a little bit. So 196 times, I'm so sorry. I feel like I'm a cheater. 196 times 333,000. That equals $65.27. So now, that is what I'm saving off the total price. But now I have to take that and subtract that for $196. So I'm going to say $196 minus 6.
Hello?
Hello?
Yes.
Are you with me right now?
Yes.
So you understand what I'm doing now, correct? I found how much I'm saving.
You just found how much you lost.
I found how much I lost. And I saved lost already. So I'm going to take that. That's all I have to do.
That's all you have to do.
That's all I have to do. I'm sorry. Your answer is $65.27.
Okay.
All right, Olivia?
Olivia, were you clear on how he came up with this answer? I know he did that a little quickly. So you good?
Yes.
She was with me every step. What I did, Olivia, I substituted, I'll use those big words, I substituted my C, which was my cost, which is $196, times my rate, which is 33 1/3, excuse me. Because they are side by side, which means they multiply. So I just multiplied them together. Now, I think it's best for you to change it to a decimal.
Yes.
Rather than improper fraction.
I would
but,
too.
You know, we do whatever comfortable for you. Okay? And so when I multiply together, I found out my loss, which is L, is equal to $65.27. Okay?
Okay.
Thank you. Anytime. Did you want to try Challenge 24, Olivia? Did you want to try Challenge 24? Or 24 Challenge, however you say it?
Sure.
Okay,
Sure, yeah.
Okay, here we are. Yeah. The card is up there. Take a look at those. A, B, C, or D.
Can I try A?
All right.
Okay, 9485.
Okay.
So did you write it down? You going to call us back or you want to try it now?
I'll call you back.
Okay, talk to you in a little bit.
I love students.
Me too. Who do we have next on the line? Geraldine, is that you?
Hello?
Hey,
Hello.
Geraldine, how you doing?
Welcome back.
Good.
Welcome back.
I have the 24 ready.
All
Okay,
right.
let's hear it.
And I actually found 2 ways.
Okay.
Well, we only want one, okay? Just give us one way.
Yeah, okay.
All right, let's do it. Which card did you choose?
3, 4, 7,
Okay.
7.
I chose card D.
Okay, 3, 4, 7, 7, correct?
Yes.
Okay, let's go.
Okay. I did 7, times 3 equals 21.
She's going to do it a different way. I just know it.
And 21 plus 7 equals 28. 28 minus 4 equals 24.
Good, sir.
Good. 28 minus 4 equals 24. Ring that bell.
I say Geraldine's in the building. Great job, Geraldine.
Excellent job, Geraldine. You
and
got
your name
the
is going
24.
inside the treasure chest not once, but twice,
Your name
but
is
3
in there for
times.
the second time in it. What is the third time?
Did she do something earlier twice?
No, she only did it once.
Oh, it was
so
twice.
It's the second time. Okay, so your name is in there twice. Stick around to the end of the show to make sure.
I like you, Geraldine. I like you.
To see if you won our special treat at the end of the show.
Mathematical practice number 1. Persevere. Continue to
do it.
Good job, Geraldine. All right, let's go to the next caller.
So who's next?
Hello, Terrell? Terrell? Can you hear me now? Terrell? Well, hello, Terrell. Well, Terrell, when you get your phone fixed, we call you back.
Okay, call us back, Terrell. We don't hear you. Who's next? Brian, are you there?
Yes.
Hey, Brian,
Hi,
how you
Brian.
doing? What school are you calling from?
Woodmore.
Woodmore
Yeah.
Elementary. Woo-hoo. What grade are you in, Brian?
Huh?
What grade are you in?
3rd.
3rd grade. What's your question?
Friend do a number line and mark 0 on it. After 0, he made 1 mark that was the same distance apart.
Okay, so okay, we marked 0 on our number line. And what else?
He placed the number 1 under the 4th mark.
Okay, so he put 1, 2, 3, 1 there, right?
Yes.
Okay, excellent. And then what?
And then it says, what is the distance between each mark on friend's number line?
Oh.
Okay, Mr. Pugh, you want to help him out with this one?
I'm assuming this is correctly.
Mm-hmm.
Brian?
Yes.
Are you looking at the TV screen?
What?
Are you looking at the television screen?
He is what we know.
I can't hear you.
Brian, did I draw this correctly?
Yes.
Okay, so Mr. Pugh said he's going to help you out.
So, Brian, your question is, what is the distance between each mark and the number line, correct?
Yes.
Now, Brian, what I like to do, I like to make my questions real world, okay? Mm-hmm. And I know all young kids love money. You like money? Brian, do you like money?
Yes.
Okay, Brian, imagine you have $1 and change, okay?
Yes.
They give you $1. See a little dollar right here? See that 1? See the 2 zeros? That's $1. Now, let's use this. What 4 things you know add up to $1, Brian?
Excellent job.
I can't hear you.
What 4 coins? What 4 coins you know add up together will give you $1 whole dollar?
4 quarters.
4 quarters! Oh my goodness, Brian! And so, how much is each quarter worth?
Excuse me?
How much is each quarter worth? What's the value of a quarter?
25.
25 cents. So what I'm gonna do, I'm gonna put 0.2500s here. I can't write across my chest, Brian. I'm gonna put 2500s here, 2500s here. 0.2500s there. Good. Now, Brian, watch this, Brian. So the distance between each dash on the number line is 2500s distance, okay?
Yes.
Because watch this, Brian. If I have 2 2500s, how much money is that if you have 2 quarters? If you have 2 quarters, how much money is that?
50 cents.
50 cents. So this 25 and this 25 gives me 0.50. If I have 3 quarters, that gives me 75 cents, correct?
Yes.
So therefore, 4 quarters give me $1. So the total distance of each little dash on the number line is 2500 distance. Okay.
Okay.
Thank you, Brian.
Okay.
Have a great day, sir.
You too.
Man, that was an awesome question. We're gonna allow my producer to walk through right quick so we can finish the show.
Okay, so who's next on the line? Margaret, are you next? Margaret? Margaret, are you there?
We're going to call Margaret back.
Okay, Margaret, we're waiting for you.
Maybe that's it. We did all that.
Well,
today. Good job.
Someone called back about the question for the 2x squared times 5 minus y. Remember they wanted that simplified? Is there a way that we can simplify this where we're combining the 5, multiplying it? I was explaining that this is already in lowest terms because we don't have, it's not a distributive thing.
Right, it's not a distributive problem.
Because if it was set up like this, where it's 2x squared minus y, then we could distribute that to, throughout the quantity.
Right.
So only if it was distributive property.
What are they asking? They want to ask them to simplify what?
They want us to simplify this expression.
We can't simplify that expression.
Okay, I'm trying to. Could we do this? Could we have x? No, we can't even distribute the x out.
No, we can't because there's no x other than 5 and y.
Because I was going to say maybe we could do the x outside, but we can't distribute that x out.
Oh, you can't. You can multiply. Yes, you're right. You can multiply the coefficient 2 times 5, and you get 10x squared minus y. That'd be simplified. Now, yeah.
So who was that called?
Natalia.
Natalia, if you're still watching, this could be the possible answer. If we multiplied the 5 to the 2x squared, that would give us 10x squared minus y. Try that. Take that to school with you tomorrow and find out with your teacher. Verify the answer with your teacher. But all we did was take the 5 and multiply it to 2x squared and came up with 10x squared minus y. Okay?
Okay.
All right. I think Olivia called back for the 24 challenge.
You want to take her?
Sure.
I'm going to tell you. Say you fishing with. Oh, Olivia's on the air already.
Yeah, Olivia's already on the air. Which card did you choose? Card D? 7, 7.
I did A.
Card A. 9,
5.
4, 8, and 5. Okay, Olivia, what do you have for us?
Okay, I did 5 minus 9.
5.
You mean 9
minus 5?
Yes.
Okay, 9 minus 5, so the 9 and the 5 are gone.
And I got 4. And then 4 times 4.
4 times 4.
I see it coming. I hear it coming.
Equals 16.
16, excellent job.
And 16 plus 8 equals 24.
Woo-hoo! Olivia! Ooh. Yeah.
Great job, Olivia. Great job. Thank you for calling us back, okay?
And Mr. Pugh has put your name in the treasure chest for the second time. Yeah. Okay, so moving on to Rashid, our last caller. Rashid, I don't think are you there?
I don't think we have time. You could almost email us your question.
Email us your question, Rashid, so we can get it on the air for Wednesday.
And I want to say thank Ms. McKenzie for going back and solving that question for you, Ms. Natalia, because we thought about that question. You were right. We can't multiply your coefficient times the 5. We were thinking about the parentheses, the quantity. Didn't cross our minds. We was thinking too much over the problem, not underneath the problem. But it's time to shake it, rattle, and roll.
Shake.
And let's go.
Okay, let me see. Who's that lucky person? It is
David from Kenmore Middle. Right across the street.
David, you are the lucky winner of our treasure chest. So be looking for something in the pony.
And remember, every Monday and Wednesday from 5 to 6, you always count on us. We will always be here for you. Because remember, we are here
for you.